So I'm going to label these magnets 1 and 2 for ease of communication. And we're going to try to predict the direction of the magnetic field at points A, B, and C that's produced by these two bar magnets placed at a kind of a right angle to each other. All right, so point A, what we have to do is we have to imagine we have a compass, and we put a compass at point A and ask which direction would the north needle point. Well, the north needle is going to repel from magnet 1. At the same time, it's going to repel from magnet 2. So there's going to be two forces pushing on the north end of the magnet, and the resultant of those two is going to be at a diagonal. So the magnetic field at point A is going to be on this diagonal. At point B, if I put a compass at point B, which way would the north needle point? Well, I think the north needle is going to point right towards the south end of bar magnet 1. That south end of that magnet is going to pull the north needle towards it. It'll point pretty much that way. There, magnet 2 may have a little bit of an effect. However, I'm just going to assume that it's a negligible effect because magnet 2 is a lot farther away from point B compared to magnet 1. Now, point C is a tricky one. There's a lot of influences here. So if I were to put a compass right at point C, the north needle will want to attract to the south end of magnet 2. It'll also want to attract to the south end of magnet 1. And it'll also want to repel away from the north end of magnet 2. And it'll also want to repel away from the north end of magnet 1. So both of those repulsions are slightly diagonal down and to the left. So all four of those influences, what's that going to result in? It's hard to say. They might actually just cancel each other out, to be honest. There might end up being a zero magnetic field right at that one specific point. Actually, I think that's probably what it is. So I'm just not even going to draw a magnetic field there.